Hello, this is 150 video. The topic is a proof for Pythagorean theorem based on analytical geometry, or we can say coordinate proof. Okay, let A, B and C are the sides of right angle triangle. Then we have A, B, C. A square equals to B square plus C square. In other hand, BC square equals AB square plus AC square. Okay, we can define some phrases before starting the proof. Inner product of vector. Let U x1 y1 and V x2 y2 be vectors. The inner product of U and V shown by U dot V. We define U dot V as x1 x2 plus y1 y2, or the norm of U multiplied to norm of V multiplied to cosine of theta. That theta is the angle between U and V. This is theta. Next slide. Note 1. Perpendicularity of vectors. If V and U are perpendicular U and V, if U perpendicular to V, then U dot V equals 0, because U perpendicular to V, that is concluded as to theta is 90 degree. So the cosine of 90 is 0, so norm of U dot norm of V dot cosine of theta equals to 0, so U dot V equals to 0. Example 1. Find the angle between vectors U and V. Okay, norm of U is square root of minus 1 square plus 4 square, that is square root of 10. Sorry, square root of 17. Norm of V is square root of 4 plus 9 equals to 13. So U dot V also is minus 1 multiplied to 2 plus 4 multiplied to 3, that is minus 2 plus 12, that is 10. Okay, we have u dot v, inner product of u and v equals to norm of u, norm of v, and cosine of theta. So cosine of theta is u dot v over norm of u dot norm of u multiplied to norm of v. That is, cosine of theta is 10 over square root of 13 square multiplied to square root of 17. Okay. Next example. Find m for which u and v are perpendicular. Since u and v are perpendicular, so u dot v must be 0. Okay, so minus 3 multiply 2 plus 2 m minus 1 must be 0. Okay, minus 6 plus 2m minus 2 equals 0, so 2m equals 8. So adding 8 to both sides of this equation, we have 2m equals to 8. So m is 8 over 2, that is 4. Okay, redefine Pythagorean theorem. If A, B, C be the right angle triangle ABC, right angle triangle, then BC square equals AB square plus AC square. We want to prove this equation. So let A x1 y1 B x2 y2 and C x3 y3. When we have AB is OB minus OA, that is OB minus OA, x2 minus x1, y2 minus y1, and AC is OC, the vector OC minus vector OA, that is x3 minus x1 by 3 minus y1. So we want to find AB and AC. Okay, so because AB, because y1, because A is 90 degrees, so AB perpendicular to AC, that is the inner product of AB and AC must be 0. Okay, so AB inner product to AC is 0, so x2 minus x1 y2 minus y1 dot x3 minus x1 y3 minus y1 must be 0. Okay, that is by definition of inner product, the first definition, x2 minus x1 dot x3 minus x1 plus y2 minus y1 multiplied to y3 minus y1 equals 0. Okay, by multiply part by part, x2 x3 minus x2 x1 minus the next one x1 x3 plus x1 square. The next part, y2 multiply to the next parenthesis. Okay, y2 y3 minus y2 y1 minus y1 y3 plus y1 square equals to 0. Okay, at first we by multiplication 2 to both sides by this equation, we have 2x x2 x3 minus 2x2 x1 minus 2x1 x3 plus 2x1 square plus 2y2 y3 minus 2y2 y1, be careful, minus 2y1 y3 plus 2 y1 square equals 0. Okay, we have to select this equation. Sorry, we want to continue this page. Okay, this will be good. Adding this, we have x1 square and y1 square. Okay, we add the x2 square, x3 square plus y2 square, y3 square to both sides of this equation. We have x1 is 2x1 square plus x2 square plus x3 square and these ones plus 2x2 x3 minus 2x2 x1 minus 2x1 x3 plus 2y1 y2 y1 minus 2y2 y1 minus 1 2 the first one 2y1 y3 plus y1 is 2y1 square plus y2 square plus y3 square equals to, we adding this part. Okay, we have the next side of equation x2 square plus x3 square plus y2 square plus y3 square. Okay, we have to organize this equation by this time, the composition, this one and this one. Okay, this one. Okay, x1 square plus y1 square minus x1 square x1 x3 x1 x2 square minus 2x1 x2 plus x1 square plus x3 square minus 2x1 x3 plus y1 square from this one plus y2 square minus 2 y1 y2 plus y1 square, the other one as or this term, y3 square minus 2 y1 y3 equals to x2 square plus x3 square, and this one minus 2x2 x3 plus y2 square plus y3 square minus this one sorry, y1 y3, this one y2 y2 y3. Okay, the one step remain. x1 minus x2 square plus x1 minus x3 square plus y1 minus y2 square plus y1 minus y3 square equals to x2 minus x3 square plus y1 minus y2 square. Okay, please be careful, this one and this one we can write for A is x1 y1, B is x2 y2, C is x3 y3. So x1 x2 y1 y2, this is AB square plus the next one AC square, and the other side x2 minus x3, x2 minus x3, y2 minus y3 is BC square. Okay, if we can write this one, if A, B and C are sides of a right angle triangle, then A square is B square plus C square. In other hand, when A, B, C are right angle triangle, and we shape a square on BC, the other square on AB, and the first one is over AC, and area of BCMN, the BMNC and ACDE and A is S2, ABTS is S3. If we shape the 3 square over the sides of right angle triangle, then S1 is equals to S2 plus S3. Thank you for your patience. Finish.